Hello everyone, and welcome to this example recording on the step response of an RL circuit. So the example we're going to be looking at reads as follows. Determine for the circuit below the current I for t greater than 0. That's the current flowing through the inductor, and we know that that current should be given by I infinity plus I0 minus I infinity e to the negative t over tau. So we need to get the current at time t is equals to infinity, the initial current, and the time constant. We also know that this equation is the relevant one because we can see that both when t is smaller than 0 and greater than 0, there is a current source that's connected to the circuit, which will lead to current flowing through the inductor. Right, so let's start off with the initial current. So at time t equal to 0 negative, what's going to happen? So at time t is equal to 0 negative, we are going to have your current source still present. This part of that branch falls away. The inductor becomes a short circuit. And that's 10 amps, that's 3 ohms, that's 5 ohms, and this is 5 ohms, and we're looking for the current IL. So we should be able to use current division here to say that IL is going to give you 5 over 5 plus 5 multiplied by 10 amps, which gives you 5 amps. So the current at time t is equals to 0 is going to give me 5 amps. What about when time t tends to infinity? So when time t tends to infinity, what's going to happen is that you will have your 5 ohms that's still active, but you will also have a 10 ohm that is now present, and your inductor will be a short circuit, and your 5 ohm will still be present. That will be 10 ohm, that will be 5 ohm, that's your 10 amp source, and that's 3 ohms. So again, we need to determine the current I infinity, or the current at that point, which in this case will be I infinity. How are we going to do that? We can put the 10 and the 5 in parallel. So 10 in parallel with 5 should give you 3.33 ohms. Right, so the current 10 amps is going to split between the 3.33 ohms and the 5 ohms. So we can say I infinity must give you the opposite resistor, which is 3.33 over 3.33 plus 5, all multiplied by the 10 amp source, and that should give you 3.33 over 3.33 plus 5, that's multiplied by 10, and that gives us a 3.997 amps, which is effectively going to give us 4 amps. So the current at time t is equals to infinity is 4 amps. Right, what about the time constant, which is equals to L over R? We know that L equivalent must give us the L value that was given, which is 5 henries, and RTH, which is R equivalent. What will that give us? So we would be focusing on that circuit where t is greater than 0. The source, the current source, will become an open circuit. The inductor, we can, for reference sake, we can just leave it as an open circuit so that we remember that we're looking for the equivalent resistance with respect to that point. Then you've got your 10 ohms, you've got your 5 ohms, and you've got your 3 ohms. If you inject a current in here, you'll see that the current splits as follows. It will go down here and it will come back there, meaning no current flows there, so that resistor falls out. So the equivalent resistance must be, our equivalent is going to give you 10 in parallel with 5 plus 5, which gives you 3.33 plus 5. 5 plus 3 will be 8, so it will give you 8.33 ohms. And therefore tau, which is L over R, is going to give you 5 over 8.33, and that gives you 0.6 seconds. Right, so therefore the current IT is going to give you I infinity, which was 4, plus I0, which was 5, minus I infinity, which will be 4, e to the negative t over tau, which is 0.6, and that will be in amps. So this is going to give us 4 rather, plus 1e, so it will be 4 plus e to the negative t over 0.6 amps, and that's the current. Right, and we were able to solve for the current as requested. So that's the current that will be flowing through the inductor. Thank you for watching this video and enjoy the course.